In October 2010, deep within Amboseli National Park in Kenya, a family of African elephants walked along a dry riverbed. Suddenly, the matriarch stopped, raised her trunk, and sniffed the air. A few hundred yards away, a piece of red cloth was draped over a low thorn bush. Within seconds, the herd clustered into a tight, defensive circle, placing the youngest calves in the center, while the adults began kicking up dust and rumbling in low, threatened frequencies. The red cloth belonged to a young Maasai warrior. Maasai pastoralists occasionally hunt elephants to demonstrate their manhood. Yet, when the same herd later encountered green garments worn by agricultural Kamba men, who posed no threat to them, the elephants did not pause, change direction, or alter their behavior. They walked past the fabric with total indifference. The elephants had successfully categorized two distinct cultural groups of the same primate species. How do animals actually perceive us? The common assumption is that animals view humans through a binary lens, seeing us either as generic predators to be feared or as benevolent keepers to be trusted. This view is fundamentally incorrect. Animals do not possess a single, static concept of a human being. Instead, evolutionary pressure has forced them to construct highly complex perceptual niches, treating human presence as a highly variable, multidimensional environmental force. To survive alongside us, they must categorize us not by our species, but by our specific behaviors, resources, and threat levels. To an animal, we are not a unique species. We are a shifting terrain of risk and reward. To understand how wild animals build these categories, Dr. Karen McComb, a behavioral ecologist at the University of Sussex, conducted a systematic study in the Amboseli Basin. McComb and her research team wanted to know if elephants could distinguish between human groups using acoustic cues alone. They recorded the voices of adult Maasai men and adult Kamba men saying the exact same phrase in their respective languages. Look over there, a group of elephants is coming. The researchers then placed high-fidelity speakers hidden in the vegetation near 47 different elephant family groups. When the speakers played the Maasai recordings, the elephants immediately exhibited defensive behaviors. They gathered into tight groups, smelled the air with their trunks raised, and retreated. When the speakers played the Kamba recordings, the elephants remained relaxed, showing no signs of distress. Furthermore, when the researchers played recordings of Maasai women or young Maasai boys, who do not participate in elephant hunting, the herds did not flee. The study demonstrated that elephants do not simply hear a human voice and run. They perform a rapid acoustic analysis of human language, gender, and age to calculate the exact level of risk. They decoded the subtle differences in vocal tract length and vowel pronunciation between the two human dialects to assess threat. The findings proved that animals maintain highly detailed, updated cognitive maps of human demographics. On an individual scale, animals do not just categorize groups of humans, they recognize our individual faces and pass that information down through generations. At the University of Washington, conservation biologist Dr. John Marzluff investigated how wild American crows process human identities. Marzluff and his team wore a specific latex mask depicting a caveman while trapping, banding, and releasing 7 wild crows on the university campus. They also designated a neutral mask, a depiction of a former United States president, which was worn by researchers who simply walked the campus paths without bothering the birds. Over the following months and years, whenever a researcher walked across campus wearing the caveman mask, the crows reacted with intense hostility. They formed loud mobbing groups, circling the individual and emitting harsh scolding calls. When researchers wore the neutral president mask, the crows ignored them completely. To humans, this looks like a personal grudge. It is not. It is a highly evolved survival strategy known as social learning. The crows that were never trapped learned to fear the caveman mask simply by observing the reactions of their parents and neighbors. Over a 5-year period, the proportion of campus crows that joined the aggressive mobbing when encountering the caveman mask increased from 20% to over 60%. The crows had created a cultural record of a dangerous human face, ensuring that future generations would recognize the threat without having to experience capture themselves. To an animal, we are not a unique species. We are a shifting terrain of risk and reward. On a local group scale, animals use this cognitive mapping to exploit our social hierarchies. In the forest agricultural mosaic of Bossou, Guinea, Dr. Kimberly Hawking studied how wild chimpanzees navigated. Chimpanzees navigate human settlements to raid crops. Crop raiding is a highly dangerous activity that can result in injury or death for the chimpanzees if they are caught by local farmers. Hawkins observed that the chimpanzees did not treat all humans with the same level of caution. Instead, they monitored the specific identities of the villagers. When a young man known to carry weapons or throw stones walked near the crops, the chimpanzees retreated into the forest silently, abandoning their food. However, when local women or children walked by, the chimpanzees often remained in the trees, continuing to eat papaya and maize, and sometimes even vocalizing openly. The chimpanzees had mapped the human labor division and social roles, recognizing that certain demographics of humans posed little to no threat. They did not see a monolithic human threat. They saw a complex network of individuals, some of whom were dangerous and some of whom were harmless, and they adjusted their foraging habits to maximize their caloric gain while minimizing physical risk. As we scale up to entire populations, this adaptive categorization alters the fundamental behavioral thresholds of a species. Dr. Christopher Schell, an urban ecologist, has documented this shift in North American coyotes. In rural areas, coyotes maintain a massive flight initiation distance, the distance at which an animal begins to run away from an approaching human. A rural coyote will flee when a human is still hundreds of yards away. In urban environments like Tacoma, Washington, this distance has shrunk to just a few yards. Schell's research shows that urban coyotes have learned to read human body language and path predictability. A human walking a dog along a designated concrete sidewalk is classified by the coyotes as low risk, a predictable element of the urban landscape. However, if a human steps off the path, stops, and makes direct eye contact with the coyote, the animal immediately classifies them as an active threat and flees. This is not domestication, nor is it a loss of fear. It is a highly precise calculation of human intent based on spatial cues. The coyotes have integrated the human-built environment and human walking habits into their daily survival geometry, treating us as a predictable physical force until we break that predictability. At the largest scale, the way animals categorize us can restructure entire ecosystems. Dr. Liana Zanette of Western University in Canada demonstrated this by investigating how the fear of humans ripples through food webs in the Santa Cruz Mountains of California. Zanette and her team set up hidden speakers in areas frequented by pumas. For months, they played recordings of human voices, speaking in calm, conversational tones, alongside control recordings of benign animal sounds. The pumas did not habituate to the human voices. Instead, the mere sound of a human caused the pumas to flee, reducing their active feeding time on deer carcasses by more than 30%. Because the apex predators spent less time feeding, they had to kill more deer overall to survive, which in turn altered the local vegetation patterns. Furthermore, with pumas avoiding the areas where human voices were played, smaller carnivores like raccoons and skunks increased their foraging activity, leading to a massive decline in the local songbird population. Conversely, when the team played the sounds of other apex predators like wolves or bears, the pumas did not show the same level of fear. The human voice alone acts as a super predator cue, creating a landscape of fear that reorganizes the behavior of species across multiple trophic levels. To an animal, we are not a unique species. We are a shifting terrain of risk and reward. This cognitive adaptability is not an evolutionary luxury. It is the primary driver of survival in the modern era. When we look at the urban crow, the mountain puma, or the African elephant, we are looking at minds that are being actively sculpted by our presence. For millions of years, animal cognition evolved to read the signs of the seasons, the tracks of game, and the scent of predators. Today, the most critical survival skill for many species is the ability to read the habits of a single bipedal primate. In places like Banff National Park in Canada, grizzly bears have learned to cross busy highways using specialized wildlife overpasses. Researchers have noted that the bears do not use these crossings at random. Instead, they cross almost exclusively during the hours of lowest human traffic, demonstrating a precise temporal mapping of human industrial behavior. This is the true scale of our impact. We have not just altered the physical surface of the Earth, we have forced the animal kingdom to dedicate vast amounts of neurological processing power to decoding us. Their survival depends on how accurately they can predict our next move, turning their minds into mirrors of our own societal habits.